5. Section 5 is kind of exciting. We're going to tie in everything we've been doing and connect it back to stuff that you've already learned. Today may be, for some of you, a nice set of aha moments as you figure out, okay, why do square roots even work? What is a square root? So, square roots are actually nothing more than an exponent. Specifically, they are fractional exponents. And you can see it's up on the board here as a little note, but you can see it in here in the notes. A 1/2 exponent is a square root. Square root is just a shorthand way of writing to the 1/2 power. A cube root is a 1/3 power. A 4th root is a to the 1/4 power. This changes nothing that you've already learned as far as how it works. But what it lets us do is start to tie in, okay, we actually learned the same thing already twice, but now I'm going to connect them so you actually see that they are the same thing. Now, I'm going to show you several ways to solve these problems. All of a sudden, when you start thinking of square roots and cube roots and 4th roots as powers, as exponents, you have a ton of tools that you can use to simplify them, which means there's a bunch of paths to get the same answer. So if you find something that you like that works for you, you can use that even if it's not exactly the same way I'm showing you, okay? You do still have to follow the rules, right? We can't just start doing random stuff, but if you understand how exponent rules work, and everybody look at the next page in your notes. We have a whole set, unfortunately, so you can kind of spread your notes out if you want to see both at the same time. But you have all the properties of exponents here. Now, how many of you remember seeing this before? That when I have a to the m times a to the n, I add the exponents. Or if I raise a power to a power, I multiply those. How many of you, that looks familiar to you? You think you've seen it at some point? Okay, some of you, unfortunately not all of you. So if you have questions about these rules, please ask. But a quick summary, if I raise a power or a variable to a power, a number to a power, if the base, that's what the a is here, if the bases match, I can add the exponents. This is why x to the 3rd times x squared makes x to the 5th. 3x's, 2x's makes 5x's. If I raise a power to a power, I multiply those powers. If I raise two things multiplied together to a power, each one gets that exponent. So here, and you will need to memorize these eventually, but for now, you have them in your notes. You can check them, you can refer to them. But here, AB to the m means a to the m and b to the m. This one, we did this last semester. If I have a negative exponent means 1 over that. 1 over a to the m power. It means the reciprocal. If I have, we did this one last semester too, a to the m over a to the n, that means a to the m minus n. Subtract the exponents. And again, for those of you that don't like all the variables, you've got ones with numbers in them as an example, if you like seeing the numbers in it. It's the same thing. Just know that, okay, it doesn't have to be the 30. It could be any number in there. And again, if I raise a fraction to a power, the top gets that power and so does the bottom. Those rules are going to apply to everything we do with square roots and 3rd roots and 4th roots now. So 2 ways to solve letter A here. If it'll let me get there. There we go. 2 ways to solve letter A. First way is to realize that this is the square root of 64, right? That 1/2 exponent means a square root. If you get nothing else out of today, you need to get the connection between a 1/2 exponent and a square root, a 1/3 exponent and a 3rd root, a 1/4 exponent and a 4th root. So class, what's the square root of 64? Class, what's the square root of 64? We're slowly waking up. That's better. 8. Now, what if I wanted to treat this as just an exponent instead of switching to the short, it's not a shortcut. Instead of switching to the convention of using a square root. Can I write 64 as something to a power? Is 64 something squared? What squared? 8. Does that make sense to everybody? 64 is 8 squared. And if you look at the exponent rules, we just said that if I raise a power to a power, I multiply them. Class, what's 2 times 1/2? 1, right? 2 times 1/2, the 2's cancel out, I get just 1. 8 to the first power. This is why the square root of 64 is 8. Before we're like, square root's like pairs. I look for a pair and I take it out. This is why that works. It's not that square roots have, that they like pairs. They don't like anything. This is why it works. It's because 8 squared to the 1/2 power, 2 times 1/2 is 1. They cancel. They reduce to 1. You can solve this either way on the homework. Likewise, 11 to the 1/2 times 11 to the 1/2. This is literally saying the square root of 11 times the square root of 11. Square root of 11 times 11, right? I have a pair of 11s. This should equal 11. Why does it equal 11? Because if I do the exponent rules, 1/2 plus 1/2. What's 1/2 plus 1/2? 1. This is 11 to the first power. Same idea. 2 ways to solve it. One with square roots that we're used to. One with fractional exponents using the exponent rules. Both work. Letter C. This is the cube root of -27 times the cube root of -27, right? That's what the 1/3 exponent means, is the third root. Third root of -27. Is everybody good? 27 is 3 times 3 times 3. 3 3s. That comes out. Negative comes out, because again, a negative cube root is just a negative answer. This is -3 times -3, which, yes, does make, I heard an answer over there, +9, right? -3 times -3 is +9. Let's do this with exponent rules now. I add the exponents. 1/3 plus 1/3 is 2/3. -27 to the 2/3 power. Now, you have multiple ways to go from here. One way would be to say, well, I know that -27 is -3 to the third power. That would be one way. -3 to the third power. Technically, it would be the third power raised to the 2/3. When I raise a power to a power, I multiply them. 2/3 times 3 is just 2. -3 squared. -3 times -3 is +9, just like we found up here. So all of a sudden, now that you have the exponent rules to work with, you can solve this all kinds of different ways. And it will work as long as you're following the exponent rules. You can still default to everything being roots if you want to, but that's definitely going to be the long way for some of these problems. Let's come down here. This guy. 16 to the 3/2 times 1/3. I can either do this with square roots So the 2 on the bottom means the square root of 16 raised to the third power raised to the 1/3 power, which let's not even do that. 1/3 power means a cube root. Does that make sense to everybody? The 2 on, I see and hear people being concerned here. The 2 on the bottom. 2 on the bottom is a square root. Does that make sense? 2 on the bottom means a square root. This right here. 1/2 square root. All I did was rewrite it. 1/3 means a cube root. That was on the outside. The whole thing's inside a cube root. What's the square root of 16? 4. So I have 4 to the third power inside a cube root. Well, wait a second. To the third power means there's 3 of them. Cube roots look for sets of 3. That's a set of 3 that comes out. My answer is just 4. Even faster would be to multiply the exponents. 16 to the 3/2 times 1/3. Right, just multiply the exponents. When I multiply these, either cancel out the 3 and 3, right? 3/3 would be 1. It would simplify to 1. This ends up just being 16 to the 1/2 power. 16 to 1/2 power, that's the square root of 16. Square root of 16, we already said was 4. Same answer. Do you see how I'm doing these, all of them? Every single one I'm doing 2 ways. There's even more ways. As long as you can do 1, you'll be fine. If you can do 1, that's all you need. The more tools you can use, though, the faster and easier these get. So now, this one, there's really only one easy way to do this one. Top, square root of 16. Bottom, cube root of 8. What's the square root of 16? 4. Cube root of 8, right? 8 is 2 times 2 times 2. That's a set of 2's. Comes out. 4/2 is 2. Although, why should I break my streak? Let's do this another way. You could take the 16 and the 8 and write them both as 2 to a power. So everybody go with that? That 16 is 2 to the 4th power. 8 is 2 to the 3rd power. So if I try that way, I really should be switching colors every time so nobody gets confused about the 2 different ways. Let's try that. 2 to the 4th power to the 1/2 over 2 to the 3rd power to the 1/3. Multiply the exponents. 4 times 1/2 is just 2. 2 squared. 3 times 1/3 is just 1. And then really, you could even use the fraction rule. 2 to the 2 minus 1. 2 minus 1 is 1. 2 to the 1st power. Same thing we got up here. And then they throw this at us. Just being mean. It's not a fraction, and it's negative. If you get a decimal, write it as a fraction. So if you want to give yourself a couple of hints here, 0.5 usually means over 2, right? 0.5 is a half, so it's probably something over 2. Later on, if you see a 0.25 or a 0.75, that probably means over 4. Right? Those are quarters. So this one, I need something over 2. What over 2 makes 1.5? If you're not sure, you can grab a calculator and divide it. I see a few of you, though. You've already found it. You can always just try it. Is it 2/2? No, it's 1. Is it 3/2? Yes. If you keep going, 5/2, 6/2, won't work. The only thing that makes 1.5, this is 25 to the 3 negative 3/2. two options for this one. Well, actually, let's just do one this time. 1 over that negative exponent. Negative exponents are 1 over. It's the reciprocal. This is only negative exponents. Some people get crazy with the negatives, and every time they see a negative, they make it a fraction. This is only negative exponents. This becomes 1 over 25 to the 3 over 2. That 2 on the bottom means a square root. 1 over the square root of 25 cubed. What's the square root of 25? 5, right? So I've got 1 over 5 cubed. And if you need to, grab a calculator. 5 times 5 times 5. Final answer here is 1 over 125. Let's do some homework problems. Everyone, I want you to try numbers 1, 2, and 3. 1, 2, and 3. And if you get done with those super fast, maybe try 12 down here also. 1, 2, 3, and 12. And I'm going to update the board here. It should say that your homework is all the evens, but we're doing 1, 2, and 3 right here to get a little bit of practice with the 1 and 3. I really want you guys to try those. And does it make sense that I did these all 2 different ways? You can pick one way. You don't need to do it both ways. So if you like this group, you can do that. You like that one. This is all supposed to be reviewed for math 1 and math 2. I know, and that's why I'm drawing it. It's so unavoidable. That's the problem, and that's what we're having to deal with. Everybody last month was like they were in my age of that. And it's great as long as you actually do what you help. That's right. As long as you understand how it works. That's the problem is if you're going to do anything where you are actually needing to do photometric is still a great way. Any of those full-time help, any of those things are there's hundreds of programs out there that do the same thing. They're great checking your work, but if you don't know what's happening, it's not going to help. You're not going to know if the answer gives you right or wrong. It makes sense. And so this class, the way they set it up originally, is to make sure that you actually know it. Or not to just have to do it by hand. If you're using a calculator checklist, but you have to know it.
Yeah.
So, try it.
No.
Let me know if it gets done.
That's 6 square.
Are there any questions? No. So it's going to be hard right now. When you get into the habits of understanding what's going on. So I got first one. 81 to 1.5. You can just, and you did it twice as much. You did it twice. When I do it once, you did a square of 81 times. Did that. Or you did it square times 1/2. Did not. You got the same answer. Which is why I was showing you in the notes that you guys have it turned off. You don't have to do that. And it's taking the videos will be off. And then if you need to go back and get into that, if you ever needed like my if that helps. There was a point where I was putting up the website that you run out of time. Oh yeah, putting up the minimum of everything. So I can get it to you. Go ahead and try 2 and 3. I'll take this way. So like, I have not heard that.
I don't know what he did.
Yeah, see how everything goes.
Oh, negative.
All right, let's try this. Number 1. Davian, do you get an answer for number 1? 9 is correct. Which way did you get that? What was that last one? Okay, so yeah, is everybody good with the fact that you can just do this the way we've been doing all square roots? As long as you recognize 1/2 exponent is the square root, square root of 81 is 9. That is perfectly fine. That's done. In the second period, I was catching people doing this and doing and actually this class as well. I saw a few of you doing it, of rewriting this 9 squared to the 1/2. Does everybody understand you don't need to do both of these? One way or the other is enough. These mean the same thing. It's just 2 ways of thinking about it. So if you just did the square root of 81, you're done. Let's do number 2 now. LJ, did you get an answer for number 2? 25? That's perfect. Now, how did you get that?
I did
So you like a cube root of 125, and you broke it apart. You figure out there was like 3 5s. Does everybody go with that? Comes out. But then we still have the whole time it's squared. So this was squared. This was squared. So it's 25. That's perfect. Does that make sense to everybody? That's one way. Anybody do it a different way? I want to explain what they did. Don't have to, just curious, because there's a bunch of ways to do this. We'll see. At some point, I may start having you guys, yeah. Caitlin? So did yours look like the cube root of 125 times the cube root of 125? Is that what you're describing?
Yeah.
Okay. Yeah, so essentially in taking that squared and just saying that there's two of them, that would be perfectly fine also. And that gets you 5 times 5 is 25. One more time. All under the same, okay. So all under the same radical, essentially saying that this was the cube root of 125 times 125. Yes, and then break it all apart. Get 6 5s, of which you can take out 2 sets of 3. Again, there's a bunch of ways to solve these. As long as you've got one, you'll be set. Number 3, let's get an answer here. Oh, you just volunteered, so I'll get somebody new. Nathan S., did you get an answer for number 3? So tell us one thing you can do with this. What would you be able to simplify, reduce, work out for this one? So if you're wanting to rewrite the 1/4, you can use this, right? Yeah, you could rewrite this as a 4th root. Somebody else, what do I do with the negative? 1 on top, make it the reciprocal. So you could write this as 1 over the 4th root of 16. That would be fine. 1 over the 4th root of 16. If your answer is negative, it probably just means you use the negative in the wrong spot. Negative exponents means 1 over that. So now the 4th root of 16, break apart that 16. It's made up of 4 2's, right? 2, 4, 8, 16. So what does that become? What's the 4th root of 16? Is 2. So this becomes 1 over 2. Okay, let's come down here to number 12. Anybody make it to number 12? Ethan, Ethan Rocca? What did you want to walk us through at least part of this one? What did you do here? Perfect. Right, is everybody good? We've done these, right? We've done cube root, over cube root, and then simplified. Cube root of 64 is 4. Cube root of 8 is 2. Just 2. Yes. Ooh. That only works if the bases match. So you can make it work, but you have to rewrite the 64 as an 8. Does that make sense? And it'll work then. You'll get 8 to the 2/3 over 8 to the 1/3. Subtract those. It'll become 8 to just the 1/3 on top, and the cube root of 8 is 2. You get the same answer. Does that make sense? Did everybody catch that? That in order to use the exponent rules, the bases have to match. So I can't use them with 64 and 8, but I can use them if I rewrite the 64 as 8 squared. That's what we're working towards here. That's maybe a little bit beyond where we are right now. Okay. It's kind of funny. This next part is actually easier than what you just did. So everyone, if you were stressed out by that last part, let's do something a little cathartic, a little relaxing here. I am just going to have you on examples 2 and, well, 2A through E here. We're just going to take it, if it's a fraction exponent, write it as a radical. If it's a radical, write it as a fraction exponent. 3 points, you guys, especially on the test. If it's on the bottom, that's the index of your root. So letter A here is the 7th root of x to the 3rd power. I'm done. That's my answer. All they're wanting us to do is, if it's a fractional exponent, write it as a radical. If it's a radical, write it as a fraction exponent. And again, I say fraction, they're saying rational. That's what rational means, is a fraction. This one, the problem is it's not a fraction right now. But we just said that if it's 0.5, it's probably something over 2. What divided by 2 makes 3.5? 7. So this is y to the negative 7 over 2. The negative makes it 1 over. So this is 1 over the square root of y to the 7th power. Right? The bottom number is the index. The top number is just a regular exponent. Letter C. This one's probably the easiest one yet. 1 over the 8th root of t to the 5th. 1 over the 8th root of t to the 5th power. And now we're going to go backwards. Letter D. What's the index for letter D? What's the, sorry, go ahead. Okay, that's the numerator. This is a square root, it's a 2. Does that make sense to everybody? If they don't list it, the index is 2. So a to the, I have a 5 and a 2, which one goes on top? 5 goes on top. The 2 goes on the bottom. That index is always the denominator. And again, that's what's up here. A to the 5 over 2. Here I've got 2 numbers, a 3 and a 5. Which one goes on top? 3. Which one goes on the bottom? B to the 3/5. Make sure it looks like an exponent. That one's a little ambiguous here. I'm going to rewrite it. B to the 3 over, if it'll work, why is it suddenly deciding not to make lines? 3 over 5. Good enough. And then last one here. 5xy to the 6. Wow, I'm going to need to restart my computer or something. This is having issues. 6 over 3. But wait, what's 6 divided by 3? 2. So this is really 5xy squared. All right, go ahead and look at the homework. At this point, you've got everything you need to do the front page of the homework. I want you guys to do 15, 16, 17, 21, and 22 right now. Try those in the next 3 or 4 minutes. They should be super fast. If they're not, raise your hand and ask, what am I doing wrong? Why isn't this working? What am I supposed to be doing? Because these should go real fast for those. 15, 16, 17, where you're taking it from, actually, I already wrote the answer to 15 up there. They're still from last period. Got a little hint there. Try 16, 17, 21, and 22. If you've already done those, do some of the other even ones on the front page. The bottom number is the type of root. So 2 on the bottom, square root. 3 on the bottom, that's all you got to do. And if you're not sure, like, try one. And then check with someone else. Does this make sense? Like this. Oh, well, you can't do that because they don't state. Or.
He's back.
All right, let's go over those four real fast. Again, they should have been very quick. Jaime, did you get an answer for 16? Let me see how you wrote it. Yes. Cube root or third root of x squared. So it's exactly right. He's got it written like this. That's exactly what we're looking for. Next one. Julian, what'd you get for 17? Fourth root of y to the fifth power. If you got stuck on that one, the issue was remembering that 1.25 is 5 over 4, right? 5 over 4. And I gave you the little hint, if it ends in 0.25 or 0.75, it's probably over 4. And then going backwards, okay, 21. Every once in a while, we have some issues with 21. Alejandro, what'd you get for 21? Did you do 22? Okay, what'd you get for 22? Y to the 3 over 4. Okay, so that's perfect for 22. Anybody get 21? Want to volunteer to do that one? Should I call on somebody? Anybody want to do 21? Okay. Ashram, did you do 21? Okay, so let's start with the basics here. If I have a 2 and a 3, and I'm going to write that as a fraction, which one goes on the top, which one goes on the bottom? 2 on the top, 3 on the bottom. The problem is the negative. Where does the negative go? Is the negative in the exponent right now? Don't put it in the exponent. There's your answer. It's not hard, but every once in a while that negative creeps up into the exponent. We were just practicing those, and people try to make it harder than it's supposed to be. Okay, everybody, at this point, this is a good stopping point. Yeah, part students, if you have to go, you can go right now. I would suggest that you guys do at least the front page, okay? You could probably try the back page. I've given you enough that you could probably figure out the rest if you try. If you don't, we'll finish this on Thursday with you guys, but you're gonna have this homework plus another section on Thursday, okay? We'll have time during the block period to finish, but again, you'll have more homework if you choose to not do any of this tonight. So Thursday, we'll finish this one. We'll do the next section. Friday is going to be a quiz. Okay. Friday's a quiz. Again, open note, open neighbor. It'll be easy. Just practice.